Welcome to this online revision session for AQA M2, which we'll be looking at the January 2011 question 1 on kinematics involving vectors. Well, as you can see, in this particular question we have been given the velocity of a particle at time t, and in the first part of the question we are asked to find an expression for the position vector r, given that when t is 0 its position is 5i minus 7j. Well, we should know that the position can be determined by integrating the velocity vector. So in this particular case we have to integrate 4 plus 3 t squared lots of I and then 12 minus 8t lots of j, all with respect to time. So if we integrate this, we're going to get 4t plus t cubed plus some constant, let's c1, a constant of integration there, and similarly when we do the second one we're going to get 12t minus 4t squared plus a second constant of integration for the j component. Now if you remember, we were told that when t is equal to 0, v has to equal 5i minus 7j. And so if we substitute t equals 0 into the expression above, we can see all we get left with the i's is c1, so c1 must be 5, and similarly the 12t and the 4t squared are both 0, so that tells us that c2 will have to be negative 7. And so our expression for r will become 4t plus t cubed plus 5 that's lots of I, and similarly we get 12t minus 4t squared minus 7 lots of j. So 4 marks for that question. So realising in the first part that you need to integrate the expression, I'll give you 1 mark, and then obtaining the correct expression will give you the second mark. Notice there, if you've got any attempt then of obtaining c1 and c2, the constants in the integration, that will give you a mark. And then finally, for having the correct expression at the end, will give you an accuracy mark for that answer. Okay, here's the second part of the question. Part B asks you to find the acceleration. So we should know that the acceleration is the rate of change of the velocity. And so we have to differentiate the separate components. So the differential of 4 plus 3t squared will be 6t, lots of I. And similarly differentiating the component of j, the 12 minus 8t, will actually give you minus 8 lots of j. And 2 marks, quite straightforward there. 1 for the method, the fact that you're going to differentiate, and 1 for obtaining the correct answer. In part C, we are then told that the particle has a mass of 2 kilograms. Find the magnitude of the force acting on the particle when t equals 1. Well, we know that force is equal to mass times acceleration, and we want to know what the force is when t equals 1. So if we take t equals 1, that will tell us that the acceleration, substituting it in, is equal to 6I minus 8j. And then we've got a choice. We can either then write the force as a vector and then find its magnitude, or we can find the magnitude of the acceleration and then multiply it by the mass to get the magnitude of the force. I'm going to do it as a vector first. So the force will be equal to, multiplying through by 2 will equal 12I minus 16j, and that will be in newtons. And then to get the magnitude of that force, so that's just F, or F is a vector with parallel lines either side to give you the magnitude. To get the magnitude of a vector, we apply Pythagoras to the vector, so it will be equal to 12 squared, that's the component of I, plus negative 16 squared, that's the component of j, and then the whole thing will need to be to the square root or to the power of a half. And 12 12s happen to be 144, and 16 squared is 256. Add those together, it happens to give you 400, and the square root of 400 is 20 newtons. Okay, again, method mark for using the fact that force is mass times acceleration. The correct expression for the force is 12I minus 16j. And then applying an appropriate method, i.e. Pythagoras, to the components. And give you a mark, and finally an accuracy mark for getting the 20 newtons. Well, hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.